Hello everyone. Today I'm going to present the theoretical foundations of wireless communication systems. Wireless communication is something we use every day. We use it for Wi-Fi, mobile networks, Bluetooth and many other technologies. But behind these technologies, there are important theories that make everything work. So in this presentation, I will explain how data is converted into signals, how signals are transmitted through the air, how multiple users share the same wireless medium, and how Wi-Fi networks operate. So let's start with the basic network architecture. To understand wireless communication, we first need to understand how networks are organized. The OSI model has 7 layers: physical, data link, network, transport, session, presentation, and application. The TCP/IP model has 5 layers: physical, data link, network, transport, and application. In wireless communication, the most important layers are the physical layer and the data link layer. The physical layer handles signal transmission, data rate, and bit synchronization. The data link layer handles framing, addressing, and media access control. In wireless networks, these layers are more challenging because the medium is open air, which is affected by noise and interferences. Now let's understand the differences between data and signals. Data is information such as text, numbers, audio, and videos. But data cannot travel directly through the air. So data must be converted into a signal. A signal is an electromagnetic representation of data. Both data and signals can be analog, which is continuous values, and digital, which has discrete values like zeros and ones. Wireless communication uses signals to carry data from one device to another. Moving on, wireless communication uses basic analog signal called a sine wave. A sine wave has three important characteristics. The first one is amplitude. This shows the strength or power of a signal. The second one is frequency. This is the number of cycles per second measured in hertz. Higher frequency means higher data capacity. The third one is phase. This shows the position of the signal relative to time. By changing amplitude, frequency, or phase, we can encode digital data into the signal. What is modulation? Modulation means converting digital data into an analog signal that can travel over radio frequencies. This is very important because wireless systems operate only within certain frequency ranges, and these frequencies are regulated to avoid interference. In modulation, we use a carrier signal and change its properties based on the data. This allows efficient wireless transmission. There are four main types of modulation. The first one is ASK. This is when only amplitude is changing. The second one is FSK. This is when only frequency changes. The third one is PSK. This is only when the phase is changing, and also this is used in Wi-Fi and Bluetooth. The last one is QAM. This is when both amplitude than phase changes. And also, this method is very efficient and used in high speed wireless systems as well. Now, let's see how multiple signals share the same channel. This is done using multiplexing. In frequency division multiplexing, different signals use different frequencies. In time division multiplexing, signals share the same channel but take turns in time. In orthogonal multiplexing, the channel is divided into many small subcarriers. This method is highly efficient and used in modern Wi-Fi. And also, multiplexing improves bandwidth utilization as well. Multiplexing manage signals, but multiple access manage multiple users. This is called channelization. FDMA is when each user gets a separate frequency band. TDMA is when users transmit in different time slots. OFDMA means when users assign different subcarriers, and this allows many users to transmit at the same time. And also, OFDMA is used in Wi-Fi 6, 4G LTE, and 5G. Devices needs to both send and receive data. This is called duplexing. FDD is when uses two separate frequency bands and sending and receiving happens at the same time. TDD is when using one frequency band and when devices take turns in time. Basically, TDD is commonly used in Wi-Fi and modern networks. Wireless communication requires antennas. Antennas transmit and receive electromagnetic waves. There are two main types of antennas. The first one is omnidirectional antennas. These are sending signals in all directions, and these are the antennas which is used in Wi-Fi routers as well. The second type is unidirectional antennas. These are sending signals in one focused direction, and these are used for long distance communication. Wi-Fi follows the IEEE 802.11 standard. The network structure it is called a basic service set, and the short term is VSS. This includes wireless devices and an access point. The access point connects devices and manage communication. Without an access point, devices can form an ad hoc network. Wireless networks use CSMA to avoid collisions. The steps are: first, check if the channel is free. Then, wait for a short time. Then, wait a random block of time. Then, they transmit data. These steps reduces the chance of multiple devices sending at the same time. Sometimes two devices cannot hear each other but try to send data to the same access point. This is called hidden station problem. The solution is RTS, which is request to send, and CTS, which is clear to send. This informs other devices to wait. Then the data is transmitted safely using the Mac frame. So now let's summarize the key points of this presentation. The data is converted into signals for wireless transmission. Signals are defined by amplitude, frequency, and phase. Modulation sends digital data through analog signals. Multiplexing and multiple access help share the wireless medium. FDD and TTD support two-way communication. Wi-Fi uses CSMA and RTS-CTS to manage collisions. So these concepts form the foundation of modern wireless communication systems. Thank you all for listening and have a nice day.